What if I told you that in one single dive, scientists uncovered 15 species no one had ever seen before in the Galápagos region? I dug through the expedition notes and reports, and it's mind-blowing. At 2,400 meters down, they found creatures so bizarre they defy science. But here's the real mystery. If 15 brand new species came from just one mission, how many more are still waiting to be discovered? Starting at number 15 on our list, we have Monoplacophoran's living fossil mollusk. This ancient mollusk, thought to have disappeared 380 million years ago, is a living link to Earth's ancient past. The fact that this mollusk survived so many mass extinctions proves that life can endure in ways we don't yet understand. Studying this species could provide insight into evolutionary resilience. Imagine if it can survive this long, what can we learn about how life on Earth can adapt and evolve in future climates? At number 14, we have Pacific White Skate Nursery. The discovery of this egg case nursery marks a major moment for marine biology. This is only the second confirmed nursery of its kind in the world, the first being found in Canada. The fact that such a delicate breeding ground is located in the Galápagos deep sea speaks volumes about how these ecosystems provide safe havens for young marine species. Why is the hydrothermal vent environment perfect for raising offspring? What can this reveal about deep-sea ecosystems' role in maintaining biodiversity? Number 13 on our list is Species 315, a diverse collection of new regional records. These creatures are not new to science, but they had never been documented in the Galápagos before. This highlights how much we still don't know about our own oceans. These discoveries aren't just additions to a list, they challenge our assumptions about how species migrate and survive in isolated ecosystems. What other species are out there in parts of the ocean we haven't explored yet? Coming in at number 12 is squat lobsters. These may seem like small, insignificant creatures, but in reality, they are key to maintaining the health of the ecosystem. They feed on detritus, acting as nature's cleanup crew. Without them, the vents would be overrun with waste and unable to sustain life. Their role in nutrient cycling is crucial. Could they be a model for how we can approach environmental cleanup here on Earth or even in space? The number 11 spot belongs to brittle stars. Found clinging to the mineral-rich structures around the hydrothermal vents, brittle stars are part of the vital web of life in the deep sea. They scavenge for food and help break down organic matter, keeping the ecosystem running smoothly. How do these creatures contribute to the resilience of such a fragile, extreme environment? For number 10, we have deep sea shrimp. This new shrimp species survives in the sulfur-rich waters around the hydrothermal vents. Their discovery opens up questions about how life can thrive in places where sunlight doesn't reach. These shrimp survive by feeding on chemical energy, not sunlight. Could these shrimp help us understand sustainable energy sources for future space missions, where solar energy might not be an option? Moving up to number 9, we find polychaete worms. These worms, living in the harshest parts of the vent field, consume sulfur, something most creatures can't even survive in. These worms are critical to understanding how life can adapt to extreme conditions. Could their biological processes unlock clues to life beyond Earth, where conditions are just as extreme? Our number 8 pick is deep sea fish species. A new species of fish discovered near the hydrothermal vents is adapted to live in extreme pressure and heat. These fish thrive in an environment where most life would perish. The question is, how have they evolved to survive without sunlight? Could these fish provide insights into how life might thrive on other planets where sunlight is scarce or non-existent? Number 7 on our list is Species of crabs. These crabs feed on the organic material that drifts down from the vents. They have evolved to survive in these toxic, high-pressure environments, and their presence proves that life finds a way in the harshest of conditions. What are these crabs doing for the greater ecosystem? And how do they contribute to the sustainability of life at the vents? Coming in at number 6 is new deep-sea snail species. This species of snail feeds on minerals and organic matter, surviving in the high-pressure, low-light conditions around the vents. What's fascinating about these snails is that they survive without sunlight and use chemical processes to convert minerals into energy. Could this species hold the key to bioengineering technologies that could one day help us develop new sustainable practices? For number 5, we have Pacific white skate. This species is special because of its egg-laying behaviors in the mineral-rich waters of the hydrothermal vents. This discovery highlights how the Galápagos deep-sea ecosystem provides a perfect breeding ground for species like the skate. Could this breeding process in such an extreme environment change how we think about reproductive strategies in other ecosystems? Moving up to number 4, we find Monoplacophoran mollusk living fossil. This species is an ancient survivor that has been unchanged for millions of years. Its ability to endure mass extinctions and still exist in the Galápagos proves how resilient life can be. The question is, how has this mollusk remained so unchanged while the rest of life around it evolve? How has this mollusk remained so unchanged while the rest of life around it evolved? Our number 3 pick is the Tortuga's hydrothermal vent field. This 600-meter-long field is filled with chimneys spewing hot, mineral-rich water. These vents are teeming with life, and their discovery is a milestone in our understanding of deep-sea ecosystems. How do the vents create such a unique environment? And what else could we learn about early Earth conditions, or even other planets, by studying them? In the runner-up position at number 2, we have Season's 15 new regional species. These species weren't new to science, but they were new to the Galápagos region. This shows how much of our ocean is still unexplored. Each discovery adds a new layer to our understanding of marine ecosystems and how species are distributed across the planet. Could this new knowledge change how we manage marine conservation? And finally, taking the top spot at number 1 is ClearHab, Schmidt Ocean Institute's breakthrough mapping technology. Using M3 multi-beam sonar and InSAS, the team was able to map the seafloor with 3-centimeter precision, discovering hidden species and vent fields. This breakthrough technology is a game changer for future exploration. What could we discover next with this technology? How will it shape marine conservation and our understanding of the ocean's depths? And here's where you come in. If you're as amazed by these discoveries as I am, hit that like button. It's free, and it helps spread stories like this to more people. And don't forget to subscribe, because trust me, the ocean is only getting stranger from here.